Welcome back, everybody. It's really nice to have all of you here with us on this Tuesday afternoon. We're going to continue our exploration into trigonometry, and last week we were talking about compound angles, and today we're going to talk about double angles. These are the two new types of angles that are new in grade 12. The questions kind of tend to stay the same, like I was telling you last time, but they now involve compound angles and double angles. So again, we just need to learn what a double angle is, where does it come from, how do we use them, how do we expand them, how do we do the reversal of the expansion, kind of like what we were doing with compound angles. And then we can start looking at questions from from Thursday onwards, actually, where we will be using them in questions, compound angles and double angles. Okay, so I think double is a little bit easier to understand compared to compound. So when we're talking about a double angle, it doesn't matter what the angle is, all right? So in other words, when I say it doesn't matter what it is, I mean whether you have an angle that's X, or whether you call an angle A, or whether the angle is 20 degrees, right? Double it means to multiply it by 2. So 2x or 2a or 2 times 20. And what we specifically look at is the sine or the cos of these double angles. There is such a thing as the tan of a double angle, but we would use our tan identity. So if you do see tan 2a or any sort of double angle, then it would be sine 2a over cos 2a. So a is just sort of a generic letter that gets used in textbooks, and that's why it's the one that I have here. Now, what's important to note is that compound angles gave rise to double angles. That's where we get double angles from, all right? So we know that we can write sine 2a as sine a plus a. That's what it means. And sine a plus a is a compound angle. So if we can remember now, we would have to expand that, okay? So remember, sine keeps its sign. So I would write this as sine a cos a plus cos a sine a, if you all recall from our compound angle formulae. Now, the difference with what we've got here compared to other things that we've seen is that we have created two like terms, okay? So this term over here and this term over here are like terms in the same way that y plus y are like terms. So if I say y plus y, I would end up with 2 of y. Or if I have something like this, if I have xy and I add another xy, then I have 2 of xy. And this really, this situation over here where I've just put the little star next, that's really what we've got here. Okay, sine a cos a plus cos a sine a. Sine a and cos a are being multiplied together, and then the two terms are being added. All right, so that means that I have 2 of sine a cos a. All right, and that's why sine 2a is equal to 2 sine a cos a. All right, that's where it comes from. If you see this 99.9% of the time, you're going to rewrite that. Okay, and there will be instances where they will give you the expansion and they will expect you to go back and do the reversal. Okay, so when we come this way, from here to here, we are expanding. And when we go from there back here, we're doing the reversal of the expansion. That one's really very easy. There's no other way to write sine 2a other than as 2 sine a cos a. All right, let's move on and let's talk about the cosine double angle identity. Again, cos 2a is obtained from saying cos a plus a. Again, you need to know your cosine compound angle identities in order to be able to expand this. So this expands as follows. All right, so couscous, if you remember that, so cos a, and then remember cos doesn't keep its sign, so this becomes a minus sine a, sine a. Okay, so cos a times cos a is cos squared a. And sine A times sine A is sine squared A. All right, so that is your first cosine double angle identity. Cos 2A is equal to cos squared A minus sine squared A. But there are other ways in which we can write this. And I'm going to show you those now. Again, when we are doing the expansion, we're going in this direction. And when we do the reversal of the expansion, we're going back the other way. All right, now, do you remember the square identity from grade 11? So when I talk about the square identity, I mean this one, that sine squared A plus cos squared A is equal to 1. Do you remember that? Okay, and then remember last year in grade 11, we were able to make either sine squared A or cos squared A the subject of the formula. So what I could do is I could leave sine squared A on the right-hand side, and I can take the cos squared A over to the other side, and that gives me 1 minus cos squared A on the right-hand side. Now look here, matrix, what I can do is I can take this expression over here, and I can sub in what I've got over here into this. All right, so in other words, I could do this. I'm going to take cos squared A minus sine squared A. And then from my square identity, I've got cos squared A minus, and I'm going to write what sine squared A is equal to. Remember, it's equal to 1 minus cos squared A. So now when we remove the brackets, this is like when we were in grade 8 and we were doing distribution. So we're going to multiply the 1 and the minus cos squared A by -1 when we remove the brackets, and that gives us cos squared A minus 1 plus, remember, negative times a negative is a positive, cos squared A. And again, cos squared A and cos squared A are like terms. So when I add them together, I've got 2 cos squared A minus 1. And that's where that one comes from. Okay, so the cosine double angle expansion can be written as this. It can be written as cos squared A minus sine squared A. And it can also be written as 2 cos squared A minus 1. And there's actually a third way in which we can write it. And I'm going to show you that now as well. So just like we made sine squared A the subject of the formula, so we can make cos squared A the subject of the formula. So in other words, I'm making this the subject of the formula. And that would be equal to 1 minus sine squared A. So again, I'm going to take this and I'm going to go and I'm going to sub it in here. All right, so I'm starting off with cos squared A minus sine squared A. And in place of cos squared A, I'm writing 1 minus sine squared A minus sine squared A. Here, there's an invisible plus in front of the bracket, so no signs are going to change. So I have 1 minus sine squared A minus another sine squared A. Right, and that's where 1 minus 2 sine squared A comes from. Okay, so that is how they are derived. That's where they come from. And whilst sine 2A can only be written as 2 sine A cos 2A has 3 different ways in which it can be written. Okay, so we can write it either in terms of cos and sine, or cos only, or sine only. All right, and you will see when it becomes important for us to use it in which particular form. Certainly for what we're going to be doing now over the next couple of lessons, it's not going to make any difference, but there will come a time where it makes a difference how we choose to write that. But that's when we do identities and equations. All right, so here's just a summary of the double angle formulae. So sine 2A is 2 sine A cos A, and cos 2A can be written in 1 of 3 ways. So cos squared A minus sine squared A, or 2 cos squared A minus 1, or as 1 minus 2 sine squared A. Okay, nobody will ask you how to derive those, but you know, I think it's nice to know where things come from instead of just being told, oh, well, this is equal to this, and you just accept it and move on. Okay, so that's why I wanted to explain that to you. So first things first, let's get into an example. We are first in part A, we're going to use the double angle formulae of sine to expand the following. All right, so now I just want you to watch these, and then when I'm done, I'm going to give you a couple that you're going to try as well. In fact, what I might do is do 1 and 2, and let you try these, and then we can come back and we can talk about number 3 in both of them, because I think that's an important thing for us to discuss. All right, so in number 1, all they want us to do is expand. Okay, so in number 1, they've given us sine 4a, right? So 4 is double 2, isn't it? So that means that I can write this as the sine of double 2a. Does that make sense to everybody? Very important, okay? The angle is 2a. All right, so now when I want to expand it, I'm going to write this as 2 sine 2a cos 2a. Everybody cool with that?
No, ma'am, I'm a bit lost. Why it's sine 2 and cos 2a? How did cos 2a?
Okay, do you know what, Tatso? You're going to ask that question 1,000 times before we finish this section. And lots of people do it. Okay, the cos 2a didn't appear from nowhere. It is the identity. Okay, so remember we're using the identity.
Okay.
Yeah, using the identity, okay.
Okay.
It's all right. You and every other matric and all the matrics in the years still to come, we all ask the same question, so don't stress. And I don't mind how many times you ask either. Okay, so that's why. Okay, it's because we are expanding it using the identity. That's all we're doing at the moment. Okay, so we've been given it in the same form that we see here on the left-hand side, and then we are expanding it. We're writing what we see on the right-hand side. Okay.
Thank you, ma'am.
No problem, my darling. Okay, number 2, sine 50. Okay, so just like we can work with A's and B's and X's and all that kind of thing, 50 is also a double, isn't it? Okay, it is double of 25. Exactly. So sine 2 times 25 degrees. Okay, so remember the angle is 25. So this is going to expand to 2 sine 25 cos 25. Okay, does that make sense to everybody?
Yes, ma'am.
Okay, all right. Now, I said I would come back to this one, so I'm just going to leave that one for now. And so I can do the same thing with cosine, all right? But the only difference is that I've got 3 different ways in which I can write it. Okay, so let's have a look at part B, number 1. Is that orange okay to see, Coco? Or is it hard to see? Is it good? Okay, all right. Okay, so again, this is a double angle. 6 is double of 3. Okay, so again, very important in this particular case, your angle is 3a. So I have 3 ways in which I can write this. Either I can write it as cos squared 3a minus sine squared 3a, or I can write it as 2 cos squared 3a minus 1, or I can write it as 1 minus 2 sine squared 3a. All right, and I don't have to write it in all 3 ways. It's just possible for me to do so. Okay. All right, and then the last one, this is with a number now. Let's choose a different color. Let's go with green. This is number 2. And here we've got the cos of 80. All right, so now the cos of 80, 80 is double 40. Exactly. So I can write this as the cos of 2 times 40 degrees. Okay, so that gives me cos squared 40 minus sine squared 40. Or it gives me 2 cos squared 40 minus 1. Or if I wanted to write it only in terms of sine, I could write it as 1 minus 2 sine squared 40. Okay, I want you guys to try what we're doing here at the traffic lights. Okay, maybe H will be a little bit difficult for you, but we can certainly try B and we can try E. Just before you get onto that, I just want to point something out to you, okay, that I see a lot of matrics make this mistake, and that's why every year with my own classes, it's always something that I point out. Be very careful how you write matrics, okay, because look here, if you write sine squared A, can you see how it looks like sine 2A? You need to be very, very, very careful now that you know about double angles. If you mean sine squared A, make sure you write sine squared A. If you mean sine 2A, make sure you write sine 2A. Okay, so they won't be kind to you at the end of the year. And if you've written a 2 as a coefficient instead of as an exponent, they're not going to be like, okay, well, that's fine. It's not fine. Okay, so be very, very, very careful if you mean squared or if you mean 2. Did you want to say something, Coco?
Yes, Lee, I've got a question here from Kumo. She says, ma'am, could you explain why in A, it would be 2 sine 2A cos 2A and not 2 sine A cos A?
Oh, with pleasure. Okay. The reason for that is because they gave us sine 4A. Right, I'm going to explain it to you now. So they gave us sine 4A. If they gave us sine 2A, all right, then it would be equal to 2 sine A cos A. But they doubled the double. All right, so here this is equal to sine 2 of 2A. All right, so here this is equal to sine of 2 times essentially 1A. All right, so that's why I kept saying to you, be careful, this is your angle. Okay, there's your angle, and that's what you're writing over there and over there. Here your angle is 2A, so that's why you would end up writing this as 2 sine 2A cos 2A. Does that make sense?
I've got a thumbs up.
Okay. For which question can you see, Le? For the same one. So in other words, can you see, are you asking me, is sine 4A the same as 2 times 2 sine A cos A? Is that really what you're asking?
Yes,
cool. I'm so glad you asked that question, because the answer is a big fat no. Okay, definitely not the same thing. Very common mistake. Very, very common mistake. Right, and I'm going to explain to you the difference between this now as well. These are all sorts of the little things that we need to discuss. All right, so if they give us sine 4A, can you see there? And they give us 4 sine 2A, for example. Okay. This is a double angle, and this is a double angle. The difference is where the 4 is situated, right? So here you are taking the ratio, sine 2A, and you are timesing it by 4. Compared to this one over here, where you are multiplying the angle by 4. Okay, so it's not the same thing. Right, and the reason why it's not the same thing is because it gets related back to what we see on our sine curve. All right, so the best way for me to explain this to you is as follows. All right, do you remember from grade 11 that the sine of 90 is equal to 1? Do you remember that? It's one of your special angles. Okay, but if you work out the sine of 45, so in other words, if we halve the angle, okay, so 90 is double 45, all right, is the sine of 45 1 over 2? That's not, is it? Okay, so just because we halved the angle doesn't mean that we can halve the ratio.
Your question?
So sorry, so what I was saying to you, the sine of 90 is 1. Okay. Now, if you halve the angle, all right, if you halve the angle from 90 to 45, can I halve 1 and say it's equal to a half? Does that work?
No.
No, it doesn't. Okay, so in other words, taking a ratio and multiplying it by 4 is not the same as multiplying an angle by 4, right? Because these things come from a curve. It's not from something that's linear, right? So for the one that is on the left, sine 4a, that means sine 2 times 2a, as we had discussed, which would give us 2 sine 2a cos 2a. This one over here, there are instances where you can write, so like this over here, that would be your identity. And then this would give you 2 sine 2a. So if we change that maybe to a 2 rather, maybe that would be better. 2 sine 2a. 2 sine 2a. Then you can write that as 2 times 2 sine a cos a. And that's where you could get 4 sine a cos a from. So yeah, it's not the same thing.
Oh,
I've got another question here from well, sorry, Kanyisile.
No, it's fine. It's fine. What's the next question?
For A, we don't
Yes.
need to expand it even further because it looks like there are 2 double angles, 2 sine A, 2A cos 2A.
Absolutely. Now, there will be certain situations where we would go and expand this further. Absolutely, because we can expand that further and we can expand that further. But we're just doing the introductory stuff at the moment. All right, so we're not talking about expanding that further. They just wanted us to write this as the sine or the cosine of a double angle. So that's why we were doing what we're doing at the moment. But yes, theoretically, those could both be taken further. Okay. All right, so yeah, very important that doubling the angle and doubling the ratio is not the same thing. So I hope what I've written in pink helps clear up a couple of misconceptions as well. All right, so we'll come back and we'll talk about sine A and cos A now. Let's just try, well, you guys try these. Okay, so be careful. It's not sine 60, it's sine 6 theta. Okay, so you're going to write sine 6 theta as the sine of a double angle, and you're going to do the same thing with E and with H, except those are cosines. Okay, so with Coco and I are going to give you 4 minutes. But when you're done, just pop a thumbs up into the chat and then we know that you're done and we can carry on. Okay, good luck, guys. Cool, Cassandra. Try H. Okay, all of them, Tabile. Cool, nice, well done, guys. Done, 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 done. Done, okay. I'm just going to wait like 1 more minute and then we can certainly carry on. Oh, wow. Okay, done with all of them. Okay, cool, Tatso, that's awesome. Nice. Harriet also done. Narato done. Cool. All right. Well, in that case, let's carry on. We don't want to waste any time. All right. So instead of me telling you the answer, is there somebody who would like to tell us what they got for B? Anyone?
Ma'am,
Yes, can you see them?
can I say my answer?
Please.
Ma'am, I got 3 sine 2 to the theta cos 2 theta.
So 3 sine 2 theta,
Yes, ma'am.
cos 2 theta. Is that what you got?
Yes, ma'am.
Okay. All right. Now, what's happened here, Kanisile, is you have gone the other way around. Okay. So what you were supposed to do was this. All right. Sine. It's okay, my darling. We all make these mistakes when we first start off. Okay, so that's why, even though this step with a square bracket is not necessary, you don't actually have to show it, but it does really help in the beginning. Okay, so remember, to get 6, we are doubling 3. Okay, so it's not the other way around where we are tripling 2. Okay, so it needs to be, it's just this number over here and those there that were the wrong way around. Okay, but that was a really, really good effort. So this one should be 2 sine 3 theta cos 3 theta. Okay. All right. There we go. Correct, Tabili. I quite agree with you. Okay, cos 20. Anybody want to share their answer for cos 20? Cool. Natasha, go for it.
For E, I got cos squared 10 minus sine squared 10.
Excellent. Absolutely. All right. And there's 3 different ways that you could have written that. Okay, Natasha, that's lovely. Cos squared 10 minus sine squared 10. Maybe somebody else got 2 cos squared 10 minus 1. And then the last option was 1 minus 2 sine squared 10. Awesome. Well done, Natasha. Thank you so much. Yes. Tatsu, no. This line over here, you actually don't need to show. The one that I've just highlighted in yellow is not something that you need to show. But when you are starting to do this for the first time in matric, I think it's a really good idea to write that because it helps you not to make the mistake that was made like in the beginning in question B, I think. But no, you don't actually have to do that. You can go straight from here to this. Okay, but I think this just helps in the beginning.
Okay, thank you, ma'am.
No problem. All right, so Miso says, please explain.
Just explain E, yes.
Yes, yes. Okay, so Miso, this is where Natasha got her answer from, okay? I think she probably did exactly what I've been saying, which is to write cos 20 as a double angle. So that's cos of 2 times 10. Okay, so your angle is 10 degrees, and that's where she would have ended up with her cos squared 10 minus sine squared 10. Okay, or that one over there, or that one over there. Okay, Miso, does that make sense? All right, so now, guys, this is what we were talking about earlier. This 2 over here, that 2, it's not doubling the angle. It's doubling the ratio. It's not doubling the angle. So whatever we have in our final answer, we're going to have to double it. Okay, how we have rewritten this. All right. So we're going to ignore the 2 on the outside for now, and we're just going to leave it sitting there. And then we're going to write cos, and then we know that 22 is double of 11. All right. So now our ratio needs to be multiplied by 2. So in other words, when we write cos squared 11 minus sine squared 11, we mustn't forget to times it by 2. Okay, so that's what it means. So this would be equal to 2 cos squared 11 minus 2 sine squared 11. And if you wanted to rewrite it in one of the other ways, then it would be equal to 2 times 2 cos squared 11 minus 1. So that would give us 4 cos squared 11 minus 2. Or if we wanted to write it in terms of sine, that would be 2 times 1 minus 2 sine squared 11. And that would give us 2 minus 4 sine squared 11. Is there anybody that chose to write it in this way? Anybody get that? Or this one? That's it, Pilo. Yes, Shamo, nice, good. And Cassandra, all right, lovely, well done. That's really, really great. Okay, Coco, you've got your hand in the air. Go for it.
Oh, no, I also got that answer.
Oh, did you? Okay.
Yes, I did.
All right, awesome. So me too. Okay, wonderful. Now I want us to go back and I want us to go and talk about these questions over here because we do not tend to think of 1 as a double, do we? Okay, we tend to think of 1 as an odd number. We don't think of it as a double. So I'm just going to do it here on the side for you. This, in my opinion, is really, really important. Okay, so sine A, they want us to expand this using our sine double angle formula. Now, remember, what we've been doing each time is we've halved the angle. All right, so when we had cos 22, it was 2 times 11, or sine 20, it was 2 times 10, or when we had sine 40, it was 2 times 20. So what is half of 1? A half, right? Okay, so we are going to halve the angle. So here, this is going to end up being sine 2 times 1/2 of A. Okay, because 2 times a half is 1. So then this is going to be written as 2 sine half A cos half A. Does that make sense?
Yes, ma'am.
Okay.
Yes, ma'am.
Does it make sense? Okay, so
Yes,
very,
ma'am.
very cool beans. Okay, very, very important. Okay, so sine A can also be written as a sine double angle. All right, and similarly, we can do the same thing with cos. Okay, so cos A can be written as cos 2 times half A.
Half A.
Exactly. So this can be written as cos squared half A minus sine squared half A. Go. All right. Or we can write it as 2 cos squared half A minus 1, or we could write it as 1 minus 2 sine squared half A if we needed to. Okay, so just bear those ones in mind as well. Grade 12s, you will definitely see that somewhere in your journey with trig. Yes, Kanyasile, what's your question?
Ma'am, in an exam, how would they ask these questions?
Kanyasile, this comes in a very nasty way when you are doing identities normally. All right, and when we get to that section, I will show you what it is that they like to do here. Okay, but for right now, we just need to understand that 1 is also a double. It's a double of half, and then that means that we can also write sine A and cos A using our sine and cosine double angles. But I will show you this. I will show you where it gets used. Everything that I mentioned to you in these lessons, I will show you where it gets used later on. Okay, I promise. No problem. The work that we are doing right now, these sort of basic fundamentals, this is not asked explicitly in tests and exams. So you will never write a test in grade 12 where they say to you, use the double angle formulae of sine to expand the following sine 4a. You will never get a question like that. This is the background theory information that you need to know. All right, so everything that I'm talking about now is all about your knowledge, your theory, your understanding, and then as this course develops, we'll get into the sort of where do we apply this, where do we apply this. Okay, so we've got to know all of this before we can go anywhere. All right, okay, so now here's going back the other way. All right, so I'm going to let you guys try a couple of these questions, but before I do that, let's just talk. These are examples. Sorry, the questions are over there. Okay, so now we're going back the other way, right? So what we've had before is the double angle and we expanded it. Now we're doing the reversal of the expansion. So that's what this is. Okay, this is the reversal of the expansion. Right, and hopefully this is quite easy now. In a number 1, if they give us 2 sine 3 theta cos 3 theta, where did that come from? It came from sine
6 theta.
Beautiful, Cassandra. All right, awesome. And now you should also recognize the second one. Okay, 2 sine, I beg your pardon, 2 sine A over 2 cos A over 2. Where did that come from? It came from? We've literally just spoken about it.
Sine A.
That's it, Tabile. Okay, it's sine A. All right, so everybody, you know that when I write A over 2, it means the same as half A. Okay, so that's what they're getting at there. Well done, Tabile, that's perfect. All right, and then in number 3, 4 sine x cos x. Now, we've had a conversation about this one as well. What we can do here is we can split the 4. Okay, so you can write that as 2 times 2 sine A cos A. Then this bit that's highlighted in yellow, that's your identity matrix. That's your identity. Okay, and it's going to be equal to 2 of sine 2A. Okay, we spoke about that one as well. Okay, so 4 sine x cos x is not the same as sine 4x. Okay, so we've had this conversation. 4 sine x cos x is not the same as sine 4x. Okay, anyway, I hope that makes sense after everything we've spoken about. Let's just whiz through the next one so that you guys can do the questions. All right, in number 1, B number 1, instead of me telling you, you guys tell me, what is cos squared 2a minus sine squared 2a as a cosine of a single angle? How would we write that?
Ma'am, is it cos 4 theta?
It is. Beautiful. Well done. Cos 4 theta. Good job, Cassandra. Nice. Okay, someone else. Don't be shy, guys. Even if you get it wrong, doesn't matter. We're not judging you. We're all just here to learn together. 1 minus 2 sine squared 2 theta. How should we write that?
Ma'am, is it also cos 4 theta?
Is it also cos? Is it, what do you, I heard somebody else's voice there. What do we think? Is this cos 4 theta?
Yes, ma'am.
Yes. Tumelo, what do you think?
I was just going to say the same.
Exactly, quite right, Tomato. Okay, so number 1 and number 2 are identical to one another. There's no difference there. Now, look carefully, Matrix, at number 3. Okay. What's wrong with it? And I use the word wrong in inverted commas. What's wrong with it?
Sine and cos are swapped around.
Absolutely. Absolutely. So Tatso, if I come along and I write 3 minus 7, and you say to me, no, Lee, we're going to write this as minus 7 plus 3. Is that okay?
Ma'am, I guess it's still going to give you the same answer.
Right, Tatsu, it is going to give you the same answer. So in other words, we can swap terms, the order of terms, as long as we keep their signs. So in other words, I can take sine squared theta, not sine 2 theta, hey guys, sine squared theta minus cos squared theta, and I can change the order of the terms, just like I did with the 3 and the negative 7. And I can write this as minus cos squared theta plus sine squared theta. Okay, but I still remember what we were talking about with the compound angles, how the right-hand side has to be identical to our formulae before we can go back the other way, like the turning of a lock. It's the same thing with this. Okay, so we cannot do the reversal of the expansion unless the right-hand side is identical to our formula. So how can I manipulate this? What can I do to it?
Divided by negative.
Why can I not divide it by negative 1, Tatso?
Ma'am, if
Okay,
we divide if we divide it by negative 1, won't it be cos squared theta plus sine squared theta is equals to 1?
Okay, but now the problem is you can't divide through by negative 1 because this is not an equation.
Ma'am.
Okay, so you can't divide by negative 1, but there is something you can do, and it is a form of dividing, but it's not as though I can just get rid of the signs by dividing through. So in other words, immediately I'm going to take your question now, all right? If you've got something like this, like, so you see you go minus x squared plus 4x plus 3 equals 0. And they tell us that
factor?
that's it. There we go. So what are we going to take out, Tatsu? We're going to take out the
minus.
Hey, on fire. Well done. That is amazing. Cool. So now we've got outside of brackets minus 1. And then, of course, here to get that plus in the middle, this has to be a negative, doesn't it? Because a negative times a negative is a positive. Sine squared theta. Sorry, my squares are terrible. After telling you guys to write them beautifully, and then mine are so terrible. Okay, so now what is inside the brackets? Matrix looks identical to our cosine double angle. The only thing is that our ratio is negative. So this is negative cos 2a. Okay, how are you feeling? Are you guys all right?
Yes, ma'am.
Cool. Cool. Okie dokes. All right. Well, you know that you can ask Coco and I any questions that you want to. We really don't mind. Zosbini, that's the most that anyone can ever ask for. As long as you are trying, that's all that matters. Okay, you can't do any better than your best. And this is difficult. This is difficult to understand. Okay, so now I'm going to task you with this in the last, oh, mind you, we might have time to do a little bit more, but there we go. So you're going to either write this as the sine or the cosine of a single angle. So in other words, you're practicing what it is that we've just done. All right, so see if you can do all of them. We'll give you 5 minutes and then we'll take it from there. Maybe what I should do, hang on, Matrix, sorry. I was naughty. I didn't copy that. Let me do this because these will be given to you. Let me just put it over there. Shame. Otherwise, it does make life a little bit more difficult. There we go. All right. So now you've got your double angles there. All right. Try those and let's see how it goes. Wow, Tatsu, you're done already. You're amazing. Okay, so cool. Tandalwetu's done. Kanisile done. Nice, guys. Cassandra's done. Tobile's done. Thelma's done. Mark's done. Ompile. Nice. Kumo. Sure. That's excellent. Didn't expect you guys to do it so fast. That's really great. Well done. I'm super, super impressed. Cool. Boichepo. Litoyende. Neo. Nice. Okay, so let's move that out the way. Cool. CD, Harriet, lovely. Good job. So let's not waste any time. Let's get straight into this. And let's write down what the answers are. Pilo, do you want to tell me what you got for A? Or are you feeling shy? Don't be shy, Pilo. Okay, maybe Pilo is feeling shy. Okay, so you should have got sine 2x. That's it. All right, thanks, Kiketso. All right, then the next one over here. I don't know if you want to pop answers in the chat. What did you get? Oh, Pilo did put in the sine 2x. Excellent. Kiketso did too. What did you get for D? Pop it in the chat if it's easier for you guys. Sine 70. Yeah, that's it. Okay, so sine 70 is correct. That's quick and easy. Good job. All right, then the next one. Yes, sine 70 is correct. Good. Okay, then with G. This should have been quite an easy one as well. Pop it into the chat if you want. That's it. Good, Natasha. Okay, cos for theta. Cool beans. Noise. Yes, Cassandra. Chiamo. Nice. Who else got that? Boichepo. Good. Cool. Now, the next one. J. Haha. Interesting one. Come meeting controls. No, sorry. Pressing buttons here. Cos 44. Cos 44. Cos 44. Okay, there's one easy weensy teeny weeny little thing that you guys forgot. Okay, there we go, Kumo. Good. Negative cos 44. Okay, so it has to be negative because, look here, can you see again, your 1 is positive when it should be negative, and your 2 cos squared theta 22 is negative when it should be positive. All right, so this was one of those where you first had to take out the negative. All right, so that would have given us negative 2 cos squared 22 minus 1, and that would have given us negative cos 44. Well done, Kumo. You didn't fall into the trap. That was great. Good job. Nice. Nicely done, nicely done. And now the last one. The last one, sine theta, cos theta. All right, so I don't know, was it Kanisile? I'm trying to remember who, or Tato, Tobile, one of you that said to me, ma'am, where are we going to use this? All right, so let's see, what did you guys do for this one? Sine theta, cos theta. The answer will remain the same. No. So now we can manipulate this, right? So remember, a very big part of trig is the art, the subtle art of manipulation. Okay, so that means rewriting things in different ways. Almost, Natasha, but not quite, right? What's missing from the front here in order for this to be a double angle is the 2, right? So if we stuck a 2 at the front here, that would solve our problems. But we can't just go and multiply things by 2. So what we can do is we can balance out the fact that we're going to multiply it by 2 by also multiplying it by a half. Now look at this. I'm going to write a half times 2 sine theta cos theta. So in other words, I am manipulating the invisible 1 that's in front of sine theta cos theta. I'm writing it as a half times 2. Clever, isn't it? Okay, I'm writing that 1 as a half times 2, which is the same value as 1. And then this bit over here, that is your sine double angle. So this matrix is going to be half sine theta cos theta. Oh, sorry, sorry. I stopped working and my brain said completely the wrong thing. I beg your pardon. It's going to be half sine 2 theta. There we go. Does that make sense? How do you guys feel?
Amazing.
I'm so glad to hear that. That makes my night. Brilliant. Ompile, what are you saying? But that's not the, yeah, you see, Ompile, that's why we got to talk about this stuff, okay? Because it's not exactly what we expect, but then when we think about it, it does make sense. All right. Cool. Okay, so yes, Kamisile, the whole trick to this is rewriting or manipulating 1. It's rewriting 1 as a half times 2. Okay, because then we've got our identity, our sine double angle identity. So that becomes this over here. And then we just need to bring the half down, okay, and multiply it by a half. Okay, so I'm glad. I hope you guys are enjoying this. I so wish we had more than 1 hour. If we could be here for like 2 hours at a time, I'd be so pleased, but maybe we'd all be dead and bored by then. But yeah, I love trig. So we've literally got 6 minutes left. So what I wanted to try and get into today as well was just showing you how to do a few calculations without the use of a calculator. I don't think we'll have time for you guys to be able to practice any of this, unfortunately, but I just wanted to show you again where your special angles are so important for tricks. Okay, you're going to be using them all the time. All right, so in the case of the first one, right? You've got to be able to look at it and recognize that that is a sine double angle expansion that you've been given. Okay, so this is it in the expanded form, 2 sine 15 cos 15. So now you're going to write that as the sine of 2 times 15. Okay, so now here you don't have to write this line if you don't want to, the one with the square brackets, but it does help. This is the sine of 30, and we all know now that the sine of 30 is equal to a half. Okay, now with B, don't fall into the trap again. Okay, remember Kumo was the one that got this right. 1 minus 2 cos squared 22.5. All right, remember the first thing that we've got to do is take out the negative. I hear all of you yelling that. Right, perfect. Okay, so we're going to take out the negative. And that's going to leave us with 2 cos squared 22.5 minus 1. All right, so that gives us negative cos 2 times 22.5. And for some reason, my matrix, when we've done ones like this, 2 times 22.5, I'm like, what's 2 times 22.5? And they all say 50. And I'm like, 50? 22.5 is half of 45. Okay, so this is going to become negative cos 45. Okay, and that gives us negative root 2 over 2. That's it, yes. Cool, Natasha, cool to be there. See, you're not falling into the trap anymore. And then I think this is a really nice one to do, okay? Very, very important in my opinion. So often in matric and grade 11, or no, but you passed that stage now, it's the things that we're supposed to know that end up letting us down, okay? So if we're back in grade 9, grade 10, and they tell us to square a binomial, so like let's say we say x plus y squared, there are so many matrics that make the mistake of just squaring the first term and squaring the last term. This is wrong, okay? That's not what it means. Remember, a square in maths is an instruction to multiply something by itself. So if we're squaring a binomial, we're doing FOIL, which means there has to be a middle term. So we get x squared plus 2xy plus y squared. Okay, so the middle term was missing. This means exactly the same thing. All right, it means cos 15 minus sine 15 times cos 15 minus sine 15. It's exactly the same thing. So really, guys, when we are doing trig, we're actually also doing algebra. Okay, we can treat...
Plus sine 15?
Pardon?
Is it not cos 15 plus sine 15?
Oh, sorry. Yes, it is. It's plus. Sorry, beg your pardon. I'm not wearing my glasses tonight, Coco. Thank you. All right, so now we're going to FOIL this out. Someone's actually already put the answer in here. Who's the smarty pants? Shamo. Already got the answer. Very nice. Well done. I'm super, super impressed. Okay, where does that come from though? So very, very quickly, we're going to FOIL this out. Firsts, outers, inners, lasts. Okay, so this gives us matrix cos squared 15 plus sine 15 cos 15 plus sine 15 cos 15 plus sine squared 15. Okay, it's being skinny. Okay, sine squared 15. All right, now we end up with cos squared 15 plus 2 sine 15 cos 15 plus sine squared. Whoopsie, that is supposed to be a 15. Very, very, very badly written by me. Okay, in a million miles an hour, cos squared 15 plus sine squared 15 is equal to, Tiamo, it's equal to 1. That's your square identity matrix. Okay, and then this 2 sine 15 cos 15, we've saw from A, the 2 sine 15 cos 15 was equal to the sine of 30. So this is 1 plus a half. So the final answer, matrix, would be 1.5, or you could write it as 3/2. Okay, how do you feel? Great. Oh, I'm so happy. Oh, brilliant. Thanks, Kumo. Thanks, Thelma. That's awesome. Confident. I love it, Jamie. Tobile, very good. I'm so glad. I'm so glad. Nice, Pilo. All right, so unfortunately, this is all we have time for. That's fine, Kanyasile. This is difficult. It's something that a lot of matrics struggle with. So don't beat yourself up about it. You're here, you're taking part, you're being positive, you're trying, and that's all that matters. It is a great, great pleasure, Mark. Absolute great pleasure. I hope you enjoyed the lesson. Yeah, and I look forward to seeing you guys on Thursday.
And remember, guys, Thursday is quiz day. Don't forget.
Yes.
Thursday. Unfortunately, this is all we have time for. I'm going to leave you, Liani, to run to the grade 10 class.
That's fine. You run.
Thanks so much, guys, for joining us. Hope to see you guys on Thursday.
Thanks, Coco. Bye, everybody.